actually going on a field trip, and man am I pumped to bring this one to you guys. I've been trying to shoot this video for probably about 2 weeks now. Haven't been able to find the time to do it, but today's that day. Saturday morning, bright and early. My buddy likes to get up early, so guess what? We're gonna match his energy today. And I'm not even gonna spoil it for you guys, because you guys are gonna, I hope, love it just as much as I am. Luckily, he's just down the street from my shop, so we had to make a quick pit stop at the shop, grab some camera equipment, because man, I'm super excited to bring this video to you guys. But stay tuned, here we go. Alright guys, I hope you like that B-roll. Now, we're going to jump into a couple things that I've been wanting to do. Grayson has decided to allow us to all see. First of which being that we are actually going to be scanning, so like 3D scanning the intake manifold. Because like you saw in that B-roll, this is all about our coils and getting them mounted to the intake manifold. So I'm going to kind of show you guys the process. Grayson's going to help guys to get us there. I hope you guys enjoy. So here we go.
This geometry at that point that I need that kind of that surfacing, right?
Yeah.
And then once I have that, because I had it clamped down, then I'll come in. It'll be clamped, right? Then I'll come in with the probe and actually touch and probe those, and that gives me the exact hole location. Then I can come in and hit this, gives me that depth, right?
Yep.
Then I can come over here. I use a gauge pin because I can't get the probe in there. So I put a precision gauge pin in there, touch off the top of that, subtract it.
Okay. Yeah. Yep.
Yeah, just like so.
And you do that with that machine too, right?
Yeah, so like I want to sketch right here. I'll go device calibration, alright? I'll use ball probe.
Okay.
And then we'll go to design works. We'll create a plane first, okay? So this isn't going to be super accurate because it's moving around on me, right? But so I just made a plane right there, see it? That
okay. Yep.
So that's a plane right on that surface. Now I'll sketch here, okay?
Oh, I see.
Yeah, it's all way off, right? It's really moving on me. But you get the idea.
Yeah.
So then it's creating the true geometry for me. So I have that, it's true, so I need that for the holes and depths and all that, right?
Yep.
But then I have the scan geometry to be able to adapt the...
Oh, I see. That's sick.
Yeah, cool.
So that actually gives you basically where you would essentially create this entire plane for the radius of the part too?
Yep, exactly. Okay. So then that's how I knew to... I wonder if I still have it on here. And I think this one I made a solid model, so yeah, that's that radius right here, right?
Okay, yep.
What I really realized too about scanning, probing, all that is we're really only interested, we don't want to do a super good job, right? Because that wastes time.
Yeah.
As far as, modeling the whole thing perfectly. I'm going to increase this to step over 0.2 because the cut is too light, wasting time. So we'll do that and we'll drop the passes to 13. We'll check that. So we watch for the first pass. Not touching 1, 2, 3, 4. So I'll drop 4 passes off of that. So 9, let's try 10. Yeah, okay, so 10. So we'll do that. I'll drop the leads because that's wasting time. There we go. Same thing on this. Go to 0.2. 0.2. Drop this to 10. Shut the leads off. That's good, that's good, that's good, that's good. Alright, save that. Stop simulation. Okay. So this is where you post process, right? So I'm visually programming, and now I'm going to post process, so it's going to create the G code that the machine actually reads to do that.
So you're actually sending this directly to the machine
I'm going
from
to
here?
send it to this card right here.
Oh, and then you have to...
Yep, so
okay.
here it is. I just posted the code. Okay, here's all the code that are going to do that. And then we'll take it out, drop it in there. I wish I could post directly to it.
That would be sick. We had some breakage?
Yeah, we're just tapping a 3/16 thread here and the tap off.
Oh no.
That's a $400 tap. 15 parts and she broke, so there's something not quite right there. But I mean, it's tapped hundreds and hundreds, you know. That same tap has, so I will have to take a look at there. When that specific tap taps, it strings pretty bad. It creates a pretty bad string
Okay,
chip.
yep.
And so that gets clogged in between the flute, and then it
Gotcha.
binds up to break. So I'll probably switch that cycle to a tech tap, where it goes in,
And then comes out.
and in and out.
So the strings are a lot shorter?
Break the chip.
Yeah, gotcha.
Now we got ourselves a big piece of scrap metal here.
So this is steel.
Yeah, 1018 steel here.
Holy shit. Yeah, as you can see. Dude, that sucks. Is that just like the cost of doing business? Because this is not an inexpensive chunk of steel.
No, it's not horrible. I think it's like $22.
Oh, really? Okay.
Yeah, it's just,
But you lost a $400 bit.
I did. I lost $400 tap. That really sucks. And about, you know, 20,
However much downtime?
Downtime and 20 minutes of, we'll say 20 minutes of machine time that I have invested in that, right?
Okay. Damn, that sucks.
That's not the first time that's happened.
So are you like constantly ordering all the bits and pieces and everything too?
Always.
Always.
Every day.
Every day.
Every day. I have limits on all my tools, like tool 41, my face mill. I can run that on 45 parts. 42 is an end mill. I can run that on 15 parts. 43 is a finishing tool, so I don't even have it set up as a limit. I just change it when I want to.
Okay.
52 is the engraving tool. I change that at 30 parts.
Guys, this is crazy. Like actually feeling how sharp this tool still is, but yet it's junk. That is mind-boggling to me. I can't imagine what this is like brand new. At this point, you've pretty much printed everything with carbon fiber.
Yeah.
And we just found out it could be broken. So that's why we can't go with that. So now it's already made. You've made the changes for the bolt, everything. Now it's just put it in the machine.
Yep, now we gotta look at the computer, part in the computer, and figure out what size stock we need.
Okay.
So, and then we will order the stock. If we don't have it, put the stock in, And then once we have the stock, come over to the computer, start programming it, get a program, figure out what tools we're gonna have to use, you know, tool it up, and then.
And you can do all that in the.
Yep, and then go out to the saw and cut the raw material and get the vices set up, however we're gonna machine them, get the setup built, and then post the code to the machine, get the vices and the work holding set up, and then load the tooling in, and let her go.
So how long you think that might take?
Start to finish.
Yeah.
To have a completed part.
Yeah.
4 hours.
Oh, that's not bad. That's not bad at all.
Yeah, I mean from conception, basically from sitting down on the computer with nothing to selecting stock, cutting the stock, loading it, sending the work. Yeah, probably about 4 hours.
Okay. So how long until I can expect a part?
Let's shoot for next weekend.
So where can I find you? Where can we find you? Like on Instagram? Facebook?
GrayMachineCo.com is our website, and our handle on Instagram is Gray Machine Co.
I think Gray Machine Co. Yeah, okay.
Hopefully that's right. I don't know.
Yeah, I'll link it down in the description and at the bottom of the screen, but go check it out. Give this guy some support.
Thanks, guys.